Hello and welcome to today's lesson on applying Newton's second law. In this lesson, we'll begin by looking into the specific formula, F equals ma. We'll see how this matches our intuitive understanding of Newton's second law that we've developed. We'll then take care in defining the variables involved in the equation and their units. Finally, we'll go through worked examples of applying this equation to solidify our understanding. So far, we've sketched out an intuitive understanding of Newton's second law. Building on this foundation, we can now introduce the formula for this law, which will expand our understanding of how forces cause acceleration in objects. This concept advances our grasp of physics by connecting force, mass, and acceleration more precisely. Let's start by tapping into our intuitive understanding of force, mass, and acceleration, which we learnt about in the previous lesson. Recall that if you have two objects, one heavier than the other, you need to apply more force to accelerate the heavier object at the same rate as the lighter one. For example, pushing a big heavy box versus a smaller lighter box. Similarly, if you have two identical objects with the same mass, the one to which you apply a greater force will accelerate more. For example, pushing a shopping cart gently versus pushing it hard. This tells us that the greater the mass or the acceleration, the greater the force required. This forms the basis of Newton's second law of motion. Newton's second law of motion can be summed up with the equation force equals mass times acceleration. This formula aligns perfectly with our intuitive understanding. Let's break down each component, starting with force. This is the push or pull acting on an object, causing it to change its velocity. It's measured in newtons, which we've encountered earlier in this unit. We can now offer a more rigorous definition of how we measure forces. 1 newton is the force required to accelerate a 1 kilogram mass by 1 meter per second squared. Then we have mass. This is the amount of matter in an object, measured in kilograms. Mass resists acceleration, and therefore the greater the mass, the harder it is to accelerate the object. Finally, we have acceleration. This is the rate of change of velocity measured in meters per second squared. Acceleration occurs when an object speeds up, slows down, or changes direction. Let's apply what we've learnt to a few specific problems to consolidate our understanding of the equation. We'll start with some simple cases and move to more complex examples. Imagine you want to accelerate a 10 kilogram object at a rate of 3 meters per second squared. What force is required? Start with the formula F equals mass times acceleration. Then plug in the known values, so we have F equals 10 multiplied by 3. Finally, perform the multiplication, which gives us 30. So, you need a force of 30 newtons to accelerate the 10 kilogram object at 3 meters per second squared. Question 2. Suppose you are applying a force of 50 newtons to an object and it accelerates at 2 meters per second squared. What is the mass of the object? Start by using the formula. Then rearrange to solve for mass, so we have m equals F over a. Then plug in the known values, so we have m equals 50 newtons divided by 2 meters per second squared. Finally, perform the division, giving us a mass of 25 kilograms. Therefore, the mass of the object is 25 kg. Now let's use the diagram provided. Suppose in the diagram a force of 60 newtons is applied to a 15 kilogram object. What is the resulting acceleration? Start with the formula F equals m times a. Then rearrange to solve for acceleration, giving us acceleration equals force divided by mass. Then we plug in the known values, so acceleration equals 60 divided by 15. Finally, perform the division, giving us a equals 4 meters per second squared. So, the object will accelerate at a rate of 4 meters per second squared when a 60 newton force is applied. By practicing with these examples, you can see how to manipulate the formula F equals ma to solve for different variables, whether you're given force, mass, or acceleration. This reinforces the concept that these quantities are interrelated and allows you to predict and understand the effects of forces on objects. In today's lesson, we explored the equation force equals mass times acceleration, which is central to Newton's second law of motion. We introduced the formula and defined each of its components. Force measured in newtons, mass in kilograms, and acceleration in meters per second squared. We then walked through some examples of using the equation. Understanding this relationship helps predict and calculate the forces needed to move objects, solidifying our grasp of fundamental physics principles. Watch the rest of the GCSE physics course at Sophos Education.